This is Evren. Let's get into it. Physics is supposed to be the rulebook of the universe, not a suggestion, not a guideline. A set of laws so fundamental, so tested, so deeply woven into the fabric of reality that nothing should be able to violate them. And yet, space contains objects that our best models cannot fully explain, things that exist in ways that should not be possible, things that do what physics says cannot be done. And the more we look, the more of them we find. This is not fringe science. These are not conspiracy theories. These are real, observed, confirmed phenomena that sit at the edge of human understanding and refuse to fit neatly inside it. Let's start with something that should not exist at all: fast radio bursts. In 2007, astronomers detected a signal, a burst of radio waves lasting just a few milliseconds. So brief that it almost wasn't noticed. But the energy contained in that millisecond pulse was staggering, equivalent to the total energy output of the sun over 3 days, released in less time than it takes to blink. Nobody knew where it came from. Nobody knew what produced it. The signal was gone before anyone could track its source. Then more of them appeared. Hundreds, from all directions across the sky, some repeating, some never repeating, some arriving in patterns that looked almost regular, almost like something was sending them deliberately. We now know fast radio bursts exist. We do not fully understand what produces them. Every proposed explanation requires exotic physics, neutron stars colliding, magnetars flaring, or processes we have not yet named. Some bursts have been traced to specific galaxies. Others remain completely unidentified. The universe is sending signals we cannot fully decode. The second object is stranger still: white holes. General relativity, Einstein's theory of gravity and space-time, mathematically predicts their existence. A white hole is the theoretical opposite of a black hole. Where a black hole pulls everything in and allows nothing to escape, a white hole pushes everything out and allows nothing to enter. The equations allow for them. The physics does not forbid them, and yet we have never observed one. And some physicists argue we never will, because a white hole would be so unstable that it would collapse into a black hole almost instantly upon forming. But here is the uncomfortable part. Some researchers have proposed that what we observe as fast radio bursts may actually be white holes, cosmic structures so fleeting and so violent that they release an enormous burst of energy in milliseconds and then vanish. The universe may be full of objects that exist for less time than a human heartbeat. The third phenomenon breaks something more fundamental: quantum entanglement. Two particles, created together, share a connection that persists regardless of the distance between them. Measure one particle and the other, no matter how far away it is, no matter if it is on the other side of the galaxy, instantly reflects that measurement. Not almost instantly, not very quickly, instantly, faster than light, in apparent violation of everything special relativity tells us about the speed of information. Einstein called it spooky action at a distance. He believed it revealed a flaw in quantum mechanics rather than a real phenomenon. He was wrong. Decades of experiments have confirmed it is real. Particles separated by vast distances remain connected in a way that our physical intuition cannot accommodate. We can measure it. We can use it. We cannot explain why reality works this way. The fourth object is perhaps the most extreme thing in the observable universe: quasars. At the center of certain galaxies, supermassive black holes are actively consuming enormous amounts of matter. As that matter falls inward, it forms an accretion disk, a spinning ring of superheated gas moving at a significant fraction of the speed of light, and the energy released by that process produces jets of radiation that can outshine an entire galaxy by a factor of 1,000. The most luminous quasars release more energy every second than our sun will release in its entire 10 billion year lifetime. They are visible from billions of light years away. Some of the most distant objects ever observed are quasars, their light reaching us from a time when the universe was less than 1 billion years old. The physics of what happens inside an accretion disk at those extremes is not fully understood. The jets, beams of matter and energy shooting outward at nearly the speed of light, are not fully explained. The mechanism that accelerates particles to those velocities remains one of the open problems of astrophysics. These four phenomena, fast radio bursts, white holes, quantum entanglement, and quasars, are not anomalies waiting to be dismissed. They are confirmed features of the universe we live in, and what they collectively suggest is something that physicists have quietly known for decades: Our models are incomplete, not wrong, incomplete. The laws of physics we have are extraordinarily accurate within their domains, but the universe appears to contain phenomena that sit at the edges of those domains, or beyond them entirely, places where the rules bend, objects where the equations produce results that our intuitions cannot follow. The universe is not a machine we have fully mapped. It is something stranger, something that keeps producing phenomena we were not ready for, something that responds to our most powerful instruments by revealing not answers but deeper questions. Physics is the rulebook of the universe, but the universe has not finished writing it.